So, dear participants, welcome back once again. Thank you for rejoining the hands-on session. So, let's just wait for 2 minutes, then we'll start again the sessions. So, participants can locate your directory where the software is installed. So, like in my case, my device studio NanoDCAL is installed in C drive. Wherever location your directory is there, you can locate in that. So there is a 2021 version may be installed in all the participants, but 2022 version is also released. If there is a advanced things are there, we can provide you the download link for 2022 version as well. So now you can see I am going to the C drive and would like to open the software. Participants can also open their software in the bin folder. There is a device studio icon and application file is there. You can double click to open it. Once you double click on this device studio application file, this account password, you have no need to give any account detail. Login credential is not required. Just click on skip login. Once you click on skip login, this window will appear, which will ask you to use the control below to create a new project or open existing project. You want to create from beginning. So you can click on OK and save the project where you want to save. So I want to give the name of my project Nano as a hands-on training. Whatever name you come in your mind, that you can put it and click on save button. It's like project, HPF project. This window will appear in your case everyone's. And it is a device studio, which is a user interface for modeling purpose, where you can create the structures as per your needs, as per the material, whatever you want to build, the material can be created. Simulation will be done by NanoDCAL background calculation engine. These are two parts. One is called interface, second one is called simulation engine. Now participants can click on the file option and click on import button. There are multiple ways where you can import your material, in the sense load the material on which material you want to do your research. That material either you can load from the library, or you can load from third-party database, or you can create your own material. Multiple options are there. As per the needs, you can select which option is suitable for you. If you already using a third-party software, you have the CIF file, XYZ file, postcard file. That file can directly upload it from the import local option. So there are 4 ways to load your material or create the material. One is called import from local software database. Second one is called import from online open source library like material projects, open source library. And third option is called create your own material. Fourth option is called upload your existing file format in the device studio. Let's we go to the one option. Similarly, the user can also go there. In your drive location where your software is installed, you can locate that particular directory and you will find the device studio 2021, maybe A or B, both are same, but you have to locate in that. And in the material files, you have to go there and find the material, which material property you want to predict. as per your needs. Either you are working on silicon, you are working on germanium, or you are working on any other insulator, conductor, metal, semiconductor. These are all options are provided to you. Software has categorized the material as per the conductor or insulator type of the material. You can pick either your material is exist in the library or not. If not, then you have the file, then you can upload. If you want to modify the material, let's suppose MOS2 is present, you want to modify it, then a modification in the existing database is also possible. So this time, whatever material you want to simulate, let's suppose in semiconducting, you want to use any other material, you want to take gallium arsenide as an example, or anything we can take it. Even you want to take silicon, these are all materials are present. So as per your needs, you can take the material, and whatever queries, whatever error will come, that you can also let me know after some time, so that I will see what mistakes maybe you may be done. So let's suppose as an example, I can take gallium arsenide and I can click on open it. Similarly, whatever material you want to take, you can click and load, and you can maximize this view. It is a sophisticated interface. For rotation, you can hold the right button and move the mouse. Hold the right mouse, and move the mouse. For rotation of any crystal structure or material or device, molecule structure, hold the right button, then you can move the mouse for the visualizations. And to make your proper home screen, there is home button. Once you click on it, it will reach to the previous positions, normal position, by clicking on home button. It is 3D viewer window in ZY plane. Other plane can also be visualized: XY plane, XZ plane, YZ plane, YX plane, ZX plane, whatever the plane you want to see, it is up to you. You can see it. You can see here gallium arsenide.hzw. This file is loaded. We have loaded from our own library. But if you have any other things, then you can also upload. Click on import and import local. Let's suppose you have a present desktop, your material CIF file or any other file, you can find out, and from there, that particular location, you can also upload. I don't have any desktop this file format, that's why I cannot find it. But here you can see in my download folder, this file is present. So if I will upload it, this CIF file, it will definitely upload in our device studio interface. And this import online is basically when you have no material is present in our local library, neither you have file available, nor you want to find the file, material file in our local database, then this import material from project, this is called material projects open source library. So from third party database, maybe in 2022 version you can find out. In 2021 version, the API interface is not there, but 2022 version will have a proper integration with open source material library. Which material library? That I want to show you here. This is material projects just for your information. This materialproject.org, it is an open source material project library. or database website where many materials are stored in this websites. From there, this device studio can directly fetch. You can see around 1,46,323 material are already available in this database. It is a database of the material. CIF file can be downloaded from this website. YouTube video is already available how to download the material file from material projects open source library. For downloading the material, that you can type material projects. Once you type something, then you can find some already how to download a crystal structure file from material source. So these kind of already videos are available where once you will watch it, then you will see here the new material how to download. And once the CIF file is downloaded from this website, then directly either you can upload or it can directly fetch in this material, in this window in 22.2 version. Okay. And third option, as I told you, the user can create the crystal or molecule by going to the new option and crystal options, where you have to put all your input crystal information. Crystal information in the sense ABC value, alpha, beta, gamma will automatically taken care, fractional coordinate point, primitive type or conventional type, what type of crystal lattice is. That once you select it and space group. These are the four method. Why that method? You can, material will be loaded. It is not simulated. Only it will be loaded in the interface. Then manipulation, doping, defect creations, all these things can be done once the material is loaded. All type of various lattice option are there. Either it is a simple cubic, tetragonal, hexagonal, rhomboidal. These all options will be there with their symmetry operator informations. Okay. This is just like to create a new crystal from this window. Okay. You can see, and once you click on build button, the new material can be built, or you can also see the preview before going to build. And for importing from third party, that CIF file, simply file, import, local, and in download, my file is present. This file is present, so I will upload CIF file and click on import. These are the three methods that I have told you. Fourth number method will be available in 2022 version of the device studio. Now you can see this is a one gallium arsenide. Okay. If you want to change this gallium arsenide to indium arsenide, indium phosphide, or anything, let's suppose gallium arsenide we have loaded, but you want to simulate gallium phosphide. So this is your gallium and this is your arsenide, but you want to make it phosphide. You can replace the atom and there you can change it. Whatever the type or other combination you want to create, you can create like that. Now you can see here, this is not gallium, this is phosphorus. If you want to go back, this is go back, you can also undo it. If anything happen by mistake, you can undo it. These key features will save a lot of your times so that you can concentrate in your main objective goal. Like this is a gallium, this is arsenide. If you want to say it indium arsenide or anything, you can also replace this gallium to any other. This is the periodic table is there. Click on replace atom and periodic table will be opened. Participants can also play with the software. I hope you are working. Let it simulate simple material first, then you will be able to create a complex material later on. Go to the simulator and click on SCF calculation to simulate this single gallium arsenide material. SCF calculation for the crystal. You have to click on it, and here you can manipulate your parameters. If you want to change the electron temperature, whatever electron temperature, you can edit the value and put your own value. Similarly, energy cutoff, exchange correlation functions, and k point sampling, number of sampling points. Theoretical things you have to search it, and you will. And here I am going to provide you the tool trainings kind of things. This is iteration control parameter, density matrix, Hamiltonian matrix. It will solve the density functional theory matrix equations. With maximum step size are defined, mix method, mix rate, mix variable, starting mode point. These are all predefined set. Basis sets is like double zeta polarized, single zeta polarized kind of basics theories. So basis sets, these are the function that is used to represent the electronic wave function in density functional theory to turn the partial differential equation model into the algebraic equations. So double zeta type, single zeta type, what are the basis parameters are there that have to be enabled as per the desired materials. So this will basically use the appropriate resolution to identify the orbitals, either it is within the linear combination of basis functions or the expansion coefficient like that. First of all, without spin, then you can include the spin. Later on, you can click on generate file. This generate file option is there. Once the participant will click on it, you can click it. It will generate this folder icon, gallium arsenide and crystal. Once you click on this arrow on this crystal folder, arrow button is there. This arrow button, once you click on it, you will find scf.input. This scf is automatically generated script that will run in the background. If you want to run this input file, you have to right click and click on open with. This is automatically generated. What quantity should be calculated? Calculation name SCF, basic settings, calculation occupation function temperature, real space energy cutoff value. In that SCF things, like here SCF calculation, whatever we have defined that parameter from this window, whatever we have defined here, that is automatically generate in this script window. Including the coordinate point of gallium and arsenide, number of basis sets, neutral atomic database library. You have no need to do any changes, but just for your information, I want to close it. For running this input file, you have to right click and click on run button. Earlier I have clicked on open with, that's why it opened the script. Click on run button. Once you click on it, it will ask this basic gateway setting and run parallel. This license is serial license, so only one core will be utilized. Once you will have any plan for purchase, then you will get the parallel license where your workload will be divided. It will be divided in schedules, like 8 core is there, 8 times your simulation speed will be reduced, 10 times your simulation will be reduced for 10 core. For 16 core, 32 core, number of core will be increases, simulation time will be decreases. Click on run button. Once you click on it, it will automatically, this line description will generate. Whatever your material is there, whatever material you have selected, you wanted to do the research, similar procedure for every material has to be followed. You can see the calculation status has finished. Once the calculation finished, the log file, calculation log.txt file will be auto generated. Automatically generate the calculation log file. Earlier there was only scf.input file, but now log.text file has generated. You can right click and click on open with. When your simulation started, it will show that information. Like you can see here, today's date and time, at what time the calculation started, at what time the calculation finished, how much time it took to run the simulations. So time things can also be measured by this log file. Even if there is any error is there, or how the calculation is being solved, that informations are will be taken care from the log file. You can see here from the top all about the company, version, self consistent field calculation, SCF input, and their initialization and loading of their project files, system symmetry, NanoDCAL, type of NanoDCAL, parameter action correlation functionals, calculation of rigid atomic, calculation of atomic. These are all theoretical parameters it will load, and then it will solve the equations. You can see self consistent loop equations is being solved. In first step it took 2 seconds, 1 second, and it is took around 12 seconds. Total time is taken around 15 seconds, and it was finished on 17th Feb 2026. So at what time it is started, at what time calculation is finished, and you can measure the time taken by the particular single crystal. Once the number of atoms is increases, then the time will also get it increases. It may took 1 hour, it may took 5 hours, it may took 1 days, even 2 days, depending on the number of atom and your iteration control parameters. The procedure for checking the all analytics is same. Now it is done. Now we will go to the simulator for the analysis part. Material is loaded, SCF calculation parameter is defined, and simulation is run. Now, what kind of property you would like to predict? In that case, you will go to the analysis part. Just click on that analysis and you will find this density of state, effective potential, total energy, band structure, charge, assign, phonon band structure, electron density, potential, transmission, eigen, full band structure, effective mass. These all are possible. Whatever it is showing here, it is possible. Thermoelectric property will be calculated, conductance will be calculated by using the ZT feature. Out of all analysis, which property you want to predict? So you have to double click to get it select. Once you double click, it will select it. If you want to go back, you can double you can click on this backward sign. If you don't want to plot this, you can click on backward. So these two arrow are there, back and forward, reverse and forward. It is Matlab integrated. Even in potential also, different kind of potential is there. Whatever you want to see that potential, it can be predicted. This advanced things will also be covered up since it is a 2 days program. So all things cannot be explored today. Whatever rest things will be there, that will also be explored my colleague by tomorrow. So you have no need to worry. We will complete all these features. Click on generate file. Once you click on generate file, these files are generated. Since it is hands-on, so once we are going slowly, everybody can be able to model it or learn it. It is a beginning program. You may not be familiar with the tool, that's why go slowly. Now I will click on this band structure dot input, right click on that and click on run button. This window will come and click on run button. You can see here the calculation is started. Immediately the calculation will start once you click on run program. And one by one you can also able to plot the output. You can see the band structure .xml file has generated. You can right click and click on show view. Either you can see one by one or you can put all your analysis in one go, and once all simulation input file finish the calculation, then you can plot your output. So let me put my other simulation in the run program. Right click and click on run button. Just wait for 2 minutes. You can make it practice in the meantime. So you can see here, right click on that band structure, total energy, total electron density, and click on show view. There are only 2 atoms in that, but 2D model output, once you click here, at what location that maximum electron density are there.
Sir,
Yeah, please.
is there any way to get the underlying mathematical equations which are used to derive these structures?
Underline mathematical in the background information you want to know.
Yes, sir. Is there any way? I think.
Yes, theoretical things is also there. For that purpose, you can visit our websites on what
Okay, sir. I got it.
it is. Just like let me show you the documentation side, NanoDCAL, and this is theory part. So DFT NanoDCAL and NEGF in DFT NanoDCAL. This is all backgrounds.
Okay, sir. Okay, I got it.
But in the user interface, as such, no option is provided. That is available in the documentation. Okay. Now this is a electron density at what particular location it is there in terms of direction of a x, in terms of direction of y or z. Similarly, one-dimensional plot. Once the number of atoms are increases, then you can find the other output as well. And this is exchange correlation potentials output. I hope participants are able to understand for this simple single crystal, and you may be able to perform that in your computer. Normal 100 atom, 150 atom is okay. For normal laptop can also simulate. Only the time can increases. Once the number of atoms are increases around 500, 1000, 2000, even 10,000, then you require good workstations. Till now, if any participants have any questions, then you can also ask me your query.
Sir,
Hello,
in
sir.
my
Suppose if
PC,
we
hello.
Yeah, yeah,
if
please.
we are having more number of atoms, like 300, 400 atoms, what we have to do, sir?
So your question is like in this how to make the designing, or what are your main questions that you can explore in terms of
Sir,
the
if the
hardware?
cell is having more number of atoms,
Mm-hmm,
like it will have 200 atoms, the
mm-hmm,
unit cell is having,
mm-hmm.
then it will run or not?
So it will run, but time will be major things. If you will run on normal laptop, then
Okay.
it may take time. But if you have a good configuration system, then time will be reduced. Time is the major factor. Okay. So yes, one of there is one of another participant wanted to ask something. Kindly please ask.
Yes, sir, I'm trying to simulate it on my PC. So
Mhm.
I'm getting only the band structure.
Other output,
Uh,
whatever you are not able to see, we will also provide you the support. So
Total
participant.
energy, I'm not getting the total energy.
Mhm. So let me tell
Full
you.
band structure.
Mhm. Mhm.
Yes, so the same problem is arriving with me as well.
No
Uh,
problem.
I have already run the program and I have run twice, but I can't see the results.
Understand. No problem. We will provide you the support, the error, whatever you are getting. Even 2022 version has also released. Okay, in that some of the feature may not be there, that will be visible. Second thing is that if you have the Matlab, some of the output will be visualized in Matlab. Let me tell you how. You can right click on that particular project and click on open containing folder. Open containing folder. Once you click on it, the the main project where you are working currently, that project will be that folder will be opened.
Yes.
That folder you will find the total energy dot Microsoft Access table file. Just locate that particular folder and you will find the total energy Microsoft Access table. It is a Matlab file which will open in Matlab. So some of the file will be open in mostly 90%, 80%, 80 to 90% all output will be possible to display in the device studio. But 10, 15 or 20 maximum by 10, 15% will be possible in Matlab also. It is Matlab Environment software. So it will generate the output in mat format, .mat format. So if we have the Matlab software installed in your computer, and once you will load it, then you will plot the output. Okay. Even all details, all hands-on will also be provided on how to plot the output in Matlab by tomorrow. Mr. Another is speaker. So it is valid up to 28th step. Whatever your output is not visualized.
So MATLAB is required in the PC
Yes,
for
Matlab
complete
is,
understanding.
yeah, for complete all the analysis,
Because
Matlab.
because I tried for full band structure, total energy, and band structure. Out of these three, I got result only for the band structure, which I am able to see.
You total energy.
No, not total energy.
No.
In my system, I don't have MATLAB at
Okay.
present.
Okay.
But also full band structure is also not visible here.
Okay. Understand. So full band structure and another one which you told
Total energy.
total energy. Understand. So
And in
total,
open containing folder, the total energy file, the table is showing in Microsoft Access table shortcut. It is
right. This is basically a Matlab file
okay.
which will open in Matlab and it will display the value of your total energy in Matlab.
Okay.
Hmm.
So for that, MATLAB is required.
Yes, definitely.
Okay.
Definitely.
Hello, sir.
Yeah, please.
The effective mass it is not showing, sir. Already it is run.
Uh, uh, Actually we have to check it, the issue whatever maybe issue is there. Even we will also show you by tomorrow that how effective mass can be calculated. So you can follow our procedure to calculate the effective mass by tomorrow. This will be considered tomorrow session because another speaker is the expert in that, that will.
Okay.
Yeah.
Okay.
And effective mask is also required the Matlab to open it because it will generate the mat file, Microsoft Access table file, which will extract the value in Matlab. So some of the output file will be opened in Matlab.
Suppose if we have MATLAB, automatically it will generate the output.
If you have the Matlab, just you can type the command and load the file, that effective mass or total energy, whatever file, that you can load it and extract it. It will automatically extract. Only one or two command need to be input. That file need to be load and give the command to extract the data. That's it. And how it will be done, even some other output will also be shown in tomorrow session by another expert, how the data which is not plotting in device studio user interface, how it can be plotted in MATLAB. That training will be provided tomorrow. And these other analysis, whatever you wanted to see, either it is a solvent structure, phonon, jet complex, these all will be possible. And you can see some other output is there, like complex it is showing, really imagery, but those are not there. It will plot in MATLAB, and you will get to know by tomorrow how it can get it plotted, either it is effective mass, total energy, or any other output which is visualizing in the device studio. I hope it is clear till now.
Sir,
Yeah, please.
for phonon band structures as well, we require this MATLAB.
No, for phonon band structure it is not required.
Okay, okay.
But it will be possible in 2022 version, I think, which is released. So we can provide you the download link for 2022. Basically, it was released yesterday.
Okay.
We will provide you the link for that, and you can also get it installed and plot that.
Okay, thanks.
Hello, sir.
Yeah, please.
Sir, can we create graphene and zinc oxide heterostructure?
Yes, definitely. Any heterostructure you can create. This is an interface builder. So in the interface builder, you can take two material. One is called graphene, and second is zinc oxide, ZNO and graphene, right?
Yes, sir.
So you have to import the two material first in the library. Let's say you want to import the graphene. That this material is there. For making the interface, just simply go to the builder and click on interface builder. Here you have to select the graphene and ZNO and click on match. There is some theta value is different. So if we align it properly, we have to align properly, then it will be able to generate the interface as well. As in first session, I explore you how to make the interface between gold and silver. Similarly, from here, you can see here, these are different value interface builder. If it is properly aligned, your angle is properly aligning, then you can also find the lattice mismatching and you can create the interface. There is one interface heterostructure tutorial is there. So user defined project that you have to create. Like here, nickel graphene interface example is there. How step by step you can proceed. Similarly, instead of nickel, if you want to take ZNO, then you can take the ZNO and can be created. You can see here, this is like a graphene layer in the middle, top and bottom is called nickel. Graphene layer is in the middle, top and bottom, blue one is called the nickel layer. So we have to follow this procedure and then you will be able to create the heterostructures. How it can be created? You can see here this procedure. So we have to prepare your material first to make it align, and then you can create the interface. This procedure need to be followed. So basically for your particular projects that as we have provided the license for 8 days, you can prepare by yourself. But it is possible that I can insure you in the tool.
Hello, sir.
Yeah, please.
Shall we get the IV Cat6 of the interface?
For the interface, you have to create the device first. You have to define the electrode. Let's suppose you have created the interface. Then you have to make the device left electrode, central scattering region, and right electrode. And once the device is formed, created, you have to apply the vicing. Then it will generate the IV calculation. It is possible.
So tomorrow we shall create the device, I think.
Definitely. Tomorrow's session will be for device, and rest of your queries related to Matlab that will be covered up by tomorrow.
Okay, sir.
Sir,
Yeah, please.
suppose I form an interface of graphene and zinc oxide. Is it also possible to incorporate some nanoparticles at the interface in discrete positions?
Yes, I think definitely you can put it like, let me tell you. Let's suppose as an example, this is one layer. Okay. This is one graphene layer. Okay. Similarly, the interface we can create it. Okay. In the interface, if you want to put it the nanoparticles or some atomic things you want to put it, then you can see here there is a one add atom option will be there. Add atom. You can put the atom in between two atom, any two atom. This is like atom, you can select it. Now where you can put, this is like single atom that you can put as a nanoparticle on your layer. This is single layer. If you want to take it the mirror, you can sandwich the two layer in between. Like you can see here, this is one two layer system, and there is top of that there is another atom is there.
Yes, sir.
So if you want to put it, is will also be possible.
Sir,
Like
kindly explain that one, how we can add atom.
1 minute. Just for adding the atom, there is a plus button is there. You can see my cursor. Add atom. Once you click on it, you will find the periodic table. From there, you can choose which atom you want to put it. Let's suppose you want to see magnesium, you can select it. Okay. And then click the location where you want to put. I click there, this atom is there.
Okay, sir. Thank you.
Sir,
The bonding it is automatically adjusted.
There is one linker bond option is there. This is linker bond on the right side top.
Okay, sir.
There is recalculate linker bond. Once you click on it, then bonding will be shown to you. It will generate that bonding.
Thank you, sir.
Thank you.
Sir,
Yes, please.
So now this system will act like as a composite system. So the procedure for determining the band structure or some other parameters are same as earlier.
Yes, procedure is same for any other, for any output, procedure is same.
Okay.
Hello, sir.
Yeah, please.
Yes, sir. So similarly, can we design like carbon quantum dots with polymer composite polymers?
Carbon quantum dots.
Yes.
Like you want to take two different material and want to define some mole fraction alloy kind of things. You can drop me your some documented details. What kind of structure you want to create in the form of quantum dot or other composite kind of things. Then I will see it and then we'll explore you.
Okay. Thank you so much, sir.
Thank you, ma'am. So now you can also measure the distance as you send. I have click on this one atom and then another atom, and this is a distance measurement tool which measure the distance for any atom. Similar procedure is same for all the atom. Whatever you want to measure the channel length, or you want to measure the one atom to another atom distance, or you want to measure the even angle also. This is for angle measurement. Angle things, all things can be measured. Okay. And you can see I have created the mirror structure also. So there are two identical similar graphene layer is there, and if you want to move this particular atom in between the two graphene layer, then you can select this atom and click on move atom. You can move this atom. Actually something is already running in my system. 1 minute. Now you can see the atom has moved from top to in between two mid layer of the graphene. So distance, everything can be measured by you as per your needs. It's dependent to the particular users. You can click on home and then you can also get it simulate your material. And procedure need to be same follow for simulator, SCF calculation. Select the parameter and click on generate file. You can see here crystal scf.input file has generated. Right click and click on run program to run it. Program is running. Log file is generating. Once the calculation is started, log file is executing and it will get it update once the calculation is started properly. Device property is having extra. Today's only material, but device proper IV calculation, photocurrent, transmission coefficient, even and other properties that will be explored tomorrow. It is only material property is showing. Even density of state, it can also get it plot. And this is total electron density projected, or atom by atom density of state can also predicted.
Sir, for density of states, shall we measure by orbital, which orbital it is in valency band?
This is like orbital by orbital or atom by atom, and this is another option. It is possible.
Sir, I have run it by orbital. I have run it.
Mm-hmm.
It is showing so many orbitals, but it is not mentioning which atom has which orbital like that.
Okay, we will look into that, and then I will see here how you can send your screenshot on our email, and then we'll explore you. Even tomorrow session, that expert of this will explore you about that which orbital, or you can renaming or labeling things can also be done.
How we can label, sir?
One minute. Once the output is there, then there is some in a device studio. This one, like in the band structure, we define the label. One minute, I think. I will calculate the device, this density of state, then atom by atom it is showing, or orbital or by orbital it is showing. Once you will right click, then I think you will find that option. Even I have not done it, but it may be there where you can define the label of each orbital or atom. I will see it and explore you by tomorrow session how the labeling things can be done. Now the number of atoms are high in this, around 153 atom, which may took some time, but definitely it will get it simulate. Okay, and now you can see here there is these other options are there, where you can fit your atomic cell, you can make it center in x position, by positions, or you can also wrapping along ABC axis. You can stretch your cells also, stretch factor for each unit cell you can define, and you can apply some stretching strain tensors. If you want to convert your crystal into the molecule, you can see there is an option, this one, convert to molecule. You can convert your, remove the unit cell by clicking on this option. Single click and it will get it convert. And then you can also simulate that molecular structures. Now if you want to make other type of structure, you can see this builder option is there. This builder option, this device will be covered up by tomorrow. Convert your material into device will also be explored by tomorrow. Bending of device will be enabled once the device is ready. Since only material section is there, that's why this feature is disabled. Interface builder is just like to make an interface in between two material. Fill junction with CAD atomic, it is like to define the CAD geometry. It is associated basically with the CAD to atomic. Like there is one layer, you can draw the rectangle of two layer. Like this is, these are two CAD geometry we can define. Okay. And then we can go to the calculations part. Here we can define the geometry of the material properly. We can align it, define the direction, length, distance. Then it will make the interface also. Like that, you can see here the graphene. I took the graphene with their direction. Theta were not defined properly. Theta in the sense you can define the direction properly, their distance, length. And this is the interface that you can see here. And material that I have selected, this is like all carbon atom, and basically you have to prepare it accordingly from that portions. For making that, you can draw the geometry CAD to atomic. Here it is like define in that rectangular box and click on calculation, and then you have to select that atomic and their direction, length. Once you define it, then you will see the preview. Material file need to be selected. One interface I can also show as an example that is already available in the library: nickel graphene in armchair and zigzag direction. This interface with the device is already there. Okay. So similarly, you have to also create it as procedure you already explained. And if you have any problem, once you will create your own material based interface, then you can get us to us. We will try to help you.
Band structure is not coming clearly.
Not coming clear
I have
means.
done the interface of oxide. Band structure is coming some in random.
It is coming or not?
It has come, but it is something random.
Okay. So definitely.
Look like clumsy.
Okay. But like what input you have given, it dependent on the input. If there is something input is incorrect or mismatching parameter is there, then definitely the
Sir, I have
result.
given hexagonal zinc oxide structure, and also I have given graphene hexagonal structure, and then I build a interface.
Okay. So what kind of your structure you are like expecting, and what kind of other software input you have given and other output of bed structure you are getting, you can also compare it. But I don't know that what output you are getting and what input you have given, because output is totally dependent on the input. If the parameter is mismatching, then definitely the results may be mismatched. That is a part of research that you have to understand it, the physics logics behind it. But software will be very validate or reliable. You can find a lot of publication papers are there on Google Scholar that I can show you so that you will
Yes, and
see.
also in the morning you have given silver and gold heterostructure. There is a
Right,
bonding in between them.
right.
But now we are interfacing these two layers. There is no bonding.
So you can click on recalculate linker bond in between that. It will calculate the linker bond. This option is there on the top side, recalculate linker bond. You can calculate the bonding. It will calculate the bonding.
Okay.
Yeah. You can select all atom and click on recalculate linker bond.
Select an atom.
All atom.
All atom. Okay.
If bonding is possible, it will automatically create the bonding.
Okay. I think the layer distance is too far.
Definitely, definitely. If the distance is too far, then bonding will not be possible, as you already know.
Okay. Okay.
So you can reduce your distance. You can see there is a move atoms option are there. This move option is there. This one. You can move the atom. Select the atom, then you can move it. You can reduce the distance in between the atom. Then you can make the bonding. Select that atom and reduce the bonding distance. How much distance is there, how much distance you want to reduce or make it the distance in any position and vector or even in screen view.
Okay, sir. I am trying, sir.
Okay. Now once it is done, you can see here the builder option. You can make it the surface slabs, symmetry operator information and all those things. So if you want to make it surface, you can click on surface, clip the surface plane, define the clip plane Miller indices, either 100, 111, 000, whatever the plane. This is the element. You can choose that element. Surface primitive cell vector. Vacuum you can create, slab thickness you can create. And this grain boundary and nanowire will be enabled for silver or some silicon nanowire can be created. It will be enabled for these features. But for creating the crystal and molecule and other things, you can also create from here. Crystal, the same window, whatever it was opening from here, new crystal, it can also open from the crystal, molecule or device. For disordered type graphene or disordered type zinc blende type disorder, you can click on here, supercell kind of structures. This is for supercell N1, N2, you can define and create like that. This is graphene like supercell. So today's session, you just explore the tool, find out whatever property you are getting. You can also prepare your queries. Tomorrow session, we will also try to discuss on your queries topic. Whatever output you are getting, that you can remove. Whatever you are not able to get it, that we can discuss also. Okay, and how interface was created for silver and gold? For that, I want to, you can make it the practice, import local, reach to the material file, 3D material, conductor, pure metal, this folder, and locate the silver.ag. Second one, you can locate the gold.ag. So silver.hjw and gold.hjw. Interface builder, and select the structure A and structure B. Both are selected. Click on file option and click on preview. And build. Bonding will properly align. If you want to add or change the atom, let's suppose instead of gold, you want to use some other atom, aluminum. Simply select that atom. You can select this atom, draw the rectangle to select it, and click on replace atom and select aluminum or whatever the interface you want to create. It's now changed. It is silver aluminum interface. Similarly, if you want to replace the aluminum with any other, you can also replace it. One material interface you can create, and then another material, simply replace. Things can also be done. And then you can get it simulate.
Excuse me, sir. Is
Yeah,
it audible?
please. Yeah, please.
Sir, how we can change the distance between these two layer?
Okay, 1 minute. I select this atom and then you can move it. How much distance you want to move? And we want to move by direction, z direction, means direction you have to define here by moving from one atom to another layer. Like you can see here, we are moving, and you can see here, I click on that distance, I move the layer and click on recalculate linker bond, so that bonding, unnecessary bonding was happening, that has got removed. 1 minute. If you want to make it inside the lattice, just do one thing. You can select it and press center. It has reached on the same position. Undo it, and if you want to go down, select it, click on move atom. It can move like that. And you can define the distance as per the needs. Just select it and this move button and select the distance, at what distance you want to make, and you can also measure the distance, how much distance currently presently are there in between two distinct layer by using this distance measurement tool. Click on one atom and then another atom. It will measure any atom from center to center, 3.750.
Excuse me, sir.
Yes, please.
I'm not able to measure the distance. If I'm clicking on the other atom, it's reselecting itself.
Okay, 1 minute. So you can do one thing. First of all, you can click on this distance option. You can
Yes,
see
sir.
it is not enabled. Click on this so that it will enable. You can see nowadays highlight in the background.
Yes, sir.
Click on one atom, any atom, and long press control button
All right.
until you do not select second atom.
Yes, sir. I got this time.
Okay, great.
All right. Thank you, sir.
Thank you. So you can measure like that in any distance measurement tool. So not only distance, angle also, diagonal also, vector measurement, these all are measurement option. These are convert toolbar, measurement toolbar, and manipulation or movement or doping things. All things can be done here. Once you will select the particular atom, then it will be able to do that. So you can also ask your queries if any questions are there related to that, because today's session is just to make it familiarization with the user interface features that exist with the tool, and tomorrow advanced things will be also covered by another speaker, where device property calculation, phonon property calculations can be explored.
Hello, sir.
Yes, please.
I'm also not getting the bond length between two atoms, sir. I'm just clicking the distance and then I'm selecting the atom.
So you can click on one atom, then control, you can select on this distance first and press control button, long press, not not press then remove, long press until you do not click on both the atom. Got it?
Sir, it was struck, sir.
Maybe your system slow. Just click on this distance, it will get it selected. Then click on one atom and control, then another atom.
Okay, sir.
Now you are able to get it.
Sir, I'm trying, sir.
Okay, fine.
Sir, excuse me, sir.
Yeah, please.
Sir, can you once again tell us about the linkage bond, the linkage between the layers or the atoms of different layers?
Okay. This linker bond is basically calculate the bonding between atom or layers. If there is some nearby atoms are there or nearby layers are there. If any mismatchings are there, any something are not matching properly bonding, then this linker recalculate linker bond option will calculate automatically bonding. Now you can see there is no bonding is showing here. I can draw the rectangle. How? I just left press long button, long press and draw the rectangle, and then click on recalculate linker bond. It will calculate the linker bond automatically.
Answer how to remove these linker bonds?
Similarly, you can click on it. If no bonding is there, then you have to remove the distance in between. You have to select the all atom 1 minute. There is bonding are there in between two, but I have selected like that. These atom are selected in yellow color. You can move the position. Let's suppose you move up. Now this position, I don't think that should be any bonding. So now I select all atom, draw the rectangle and click on recalculate linker bond. The bonding is removed. I hope you are able to understand. And if you want to move down, simply you have to select. You can move down. Even not only NanoDCAL, we have these other simulator rescue for DFT calculations. If somebody is advanced in density functional theory or density functional perturbation theory, then this rescue software is another module. These are two different software, NanoDCAL and rescue. Even for visualization or good graphical analysis, Obito interface is there. These will be enabled in future version. BASP, LAMPS, Gaussian, Newchem interface is also there. Quantum expression interface will also be possible. Structure optimization, relaxation. Even transistors can also be simulated. Device 2-terminal and 3-terminal device characteristics plot. So till now, if any more questions, participants can also ask their queries. And for rotation also, this is an option. 1 minute, I want to show you if you want to rotate the structure. This is rotation. Clockwise, anti-clockwise, Z direction, 30 degree, 40 degree, any degree angle you can rotate your structures. So manipulation will be possible. If anything happen, you can also recalculate the linker bond.
Sir, how can we add one more layer? That
Yeah, you can add more layer also. Let me show you. Any layer if you want to add the layer. One thing is that you can create the mirror. Let me show you how to do that. Let's suppose as an example, you want to create another layer of this one, blue layer. Click on mirror. This is mirror where you can create the mirror of the same layer. There are two, you have to decide in which direction you want to create the mirror. X, Y, X, Z, Z, X, which direction. So depending on the direction, the mirror option will be there. Okay. 1 minute, I would like to show you again. Let's suppose you want to delete this layer. Press delete. Mm-hmm. 1 minute. Let's suppose as an example in this layer, any layer. This is one layer that I have copied. You can click on mirror and select that. 1 minute. It is generated this side depending on the size of that your vector. You see this option, mirror option will be there, and click on apply. Just, I think XZ direction will be taken, mirror, and from here normal vector XZ you have to take it and take the distance and click on apply. You can see on the top side it is generated. This one layer has generated. You can move down if there is high distance. Like that. So 3 layers can also be taken. Similarly, multiple layer you can also copy, and so many layer you can take it as per your need. For making center of all the layer, select it and press the center button. It will become in center in the positions. For device option, basically these are the device that will be explored the feature by tomorrow, where you can convert your material layer in the left electrode, right electrode, bottom electrode, top electrode, front electrode, back electrode. Up to 6 proof device is possible. Okay. So I'm not going to explain this today's session, but for your kind information, it is there. Okay. Till now, if any participants have any more query, you can ask.
Sir,
Yeah, please.
sir, suppose I have a simple two-layer device, let's say PN junction,
Mm-hmm.
and I want to test various type of electrodes.
Mm-hmm.
Now, can I manually change those electrodes and take the IV curve?
Definitely, it is possible. You can use aluminum electrode, gold electrode, silver electrode, any layer as electrode. That's why the periodic table option will be there. So tomorrow, basically, our speaker will try to create the material first. Then material will convert it to the device, and then whatever the device electrode are there, if you will change the device electrode, then what property effect that you can also take it. So multiple element of the material you can take as electrode, and you can vary it from the periodic table. All option by single click you can vary it, like I have shown you today how you can change the material interface structure. Also similarly the electrode can be changed. It is possible. We will explore tomorrow.
Sir, instead of these simple metallic electrodes, if I want to explore some degenerate semiconductor-based transparent kind of electrodes or multi-layered electrodes, so is this possible to have the IV curve?
Degenerated transparent electrode.
Based degenerate semiconductor-based transparent electrodes.
Which material you want to use?
So let's say doped zinc oxide.
Zinc oxide.
Yes, sir.
Yeah, I think there is restriction of material is not there. You can use any material. So it could be
Okay, sir.
possible. It could be possible. Even there even forum is also there to post the queries to the developer. So your questions can also be posted on the open forum. This is open forum website where you can create your accounts, and our main developer team of this software can also explore you different kind of electrodes.
Sir, how to draw the graphene nano ribbons? The structure of the graphene nano ribbons.
So you can go to the builder and go to the graphene nanoribbon build option on the top side and go to graphene nanoribbon. This window will appear where you can click on chiral vector n and m value, that is called chiral vector. So armchair type or zigzag type, what kind of graphene nanoribbon you want to build? Armchair and zigzag, there are two types depending on the chiral vector. You can select the structure type and click on build. Now your nanoribbon is created. Now you can further do the doping defects, either deleting the atom or changing the position. That you can also do it as per the needs. Like I deleted this atom, defect has created in the middle of this layer, like that. So defect can be created. If you want to rotate it, you can select it and click on rotate. So clockwise or anti-clockwise, whatever type, the rotation can be performed like that. 60 or any angle degree. So from today's session, I think it is I have explored a lot of things. Only user interface over idea, some questions I took. And if more questions are there, you still have 10-15 minutes. You can ask your queries and I will try to explore you. Even tomorrow, you can prepare your questions and my team will definitely answer your questions for the remaining queries that you wanted to ask today. And even we can provide you the 2022 license download link, software download link. So for phonon related property, that will be possible in 2022. So I can, my team can send you the link where you can download and install, and phonon and other property can be calculated. If you have the Matlab software, then you can also calculate the effective mass and some other total energy and some other property. And device property will be explored by tomorrow's session. So kindly we join tomorrow on time, and my other team member will be explore you fully on that. If today's session, I think it's enough because it is a one
Sir,
day.
kindly send uh, the YouTube link of this NanoDCAL or your webinar, previous webinar.
Yeah, I can send you definitely. You can even on the group. If you are already on the group, we have already sent you the link in the first session, or you can type even in your browsers this one, and you can find our YouTube channel. This link is already there. You can watch the video and perform by yourself so that you will become a familiar. And once you will familiar, then your queries will more come, and we can discuss once again on that your main goal that you want to achieve.
Sir, can we draw the multi-layer CNT, multi-wall CNT and the multi-wall CNT?
Yes, single bullet and multi bullet CNT is possible. You can also draw. That is possible. It's possible.
So can you show it how to draw, if possible?
uh, one minute. I haven't done, but it is possible. One of my colleague did that. So for that, this is nanotube. Like this is one single wallet. You have to create two single wallet, and then will assign to each other. There is one video is there, I think already available. This is one wallet, and second you can also create, and then you have to merge it. I can see there are two nanotube. One is this one, second one is this one. I have copied and pasted. Then you can move it like that you want to create. One on another is there, but once you will I will we invest our time, then fully properly we will be able to make one nanotube inside the another one.
Sir, also, if possible, please provide some reference research papers where this tool is used
Okay, definitely.
in
Even
WhatsApp group.
okay, okay,
So
one thing
that
is
will be also helpful for us.
understands, but
Okay.
for your kind information I want to see you show you that you can go to this website nanoacademic.com and
Okay.
technical insights, where these you can see product and nanodical and type recent paper that will explore. One thing is that, second thing is that Google Scholar. This
Okay,
is
in this Nano Academy.
yeah.
Okay.
So Google Scholar, once you will type it nanodecal, that Google Scholar,
Mm-hmm.
then a lot of paper will automatically you can find it out. Recent paper even from 2029. These are all already mentioned in each papers.
Okay, thanks.
Yeah. Thank you very much. So from my side, I think it is enough today's session. It is just one beginning session, and tomorrow device will be there. So I request to all the participants kindly be joined so that you will become more familiar with this innovative kind of tools. Maybe this tool can be beneficial for your research, and if you have any possibility in your university or in your institute, then you can also discuss for further for like it is a commercial tools. Okay, so 1 year license we have option, 3 year license, permanent license. Just tools, check that it is capable for your research or not. First of all, you have to validate, and if it is suitable, then definitely I request if you can think of about it, then it will be much better so that you will get the more benefited, and we will provide you the training support and whatever things is required, that will be provided. So for today's session, I think it is good enough. And thank you for your patience and